A2 Further Maths, Gantt Diagrams and Resource Histograms. Right, so what I'd like to do is just practicing some of your Year 1 skills, just see if you can complete this activity network just here and this precedence table just here. So just remembering your skills from Year 1, just see if you can fill out both of those two parts just there. Okay, so pause there, see if you remember how to do it. Okay, so the first thing you probably noticed is there's some durations missing. Now the durations are the numbers in the middle of these cells just here. So we can see the ones that are missing line up perfectly with the ones that are missing from the precedence table. So activity C just there has takes 4 hours or however long it is, 4 days. You can fill that part in just there. D takes 3, so you can fit the 3 in there, and so on. E takes 4, H takes 3, and I takes 4. So we can fill those in. Once you've filled those parts in, it doesn't really matter which way around you do this, but what I would do next is sort of start thinking about how we could fill out some of these activities. So if you look, activities A and B are the starting activities, and we can fill their durations in just there, so 5 and 10. F next is number 2, so 2 hours there. G is 1, and then we've got J at the end is 3. So we've filled out all the duration boxes. What we can do now is we can start looking at the order of the activities. So A and B are the starting activities because there is nothing that precedes them. Activity C can only be done after activity A. So what I can do is I can certainly draw a line showing that activity C must happen after activity A. And then you can go through and you can just fill in the rest. Activity D has to be done after C, same as E. So these two here can only be done after C. Activity F, this one, can only be done after B and C, so definitely C and also B. And then it's the other way around. Activity G can only be done after D and E, so I can fill those two in. Activity H can only be done after D and E as well, so we can fill those in. Activity I can only be done after G and H, so I can fill those in. And activity J can only be done after activity F. So there we go, I've filled in my precedence table and I've filled in my activity network as well. So I've shown it in two different ways. What I'd like to do now is I'd like you to have a go at seeing if you can complete the activity network by putting in both the earliest possible start times and the latest possible finish times. Okay, so just pause there and see if you can fill that in. See if you remember how to do the first pass. Okay, so I've started filling A in already. It takes no time, it's a 0 because that is the first activity. Okay, so you always put 0 in at the start time. You could do the same for B because that's a first activity as well. There's no precedence before it, no activities before it. Then we could fill in activity C. Activity C, the earliest possible start time for that is after you've completed A. Now A can start at 0, takes 5 hours, so therefore C can only start at the very earliest after those 5 hours, so I can fill that in. I could fill in D and E if I wanted to now, or I could fill in F because I got both of these. Now activity D can only be started after activity C. It takes 5 hours before C can even start, plus an extra 4 hours to complete C, so the earliest time we can start D is going to be 9. And that's true for E as well. Now for F, we've got two choices. It could be 5 hours plus the extra 4 is 9 for C, or it could be 10 for B. Now remember, there's no way you could start this at 9, even though activity C can be finished by 9, because B hasn't been completed yet. So you're always waiting for the largest out of these two choices. Okay, so although it's the earliest possible start time, it's the larger out of the two choices. So 5 and 4 is 9, 0 and 10 is 10, pick the 10. Right, so we can do the same idea with this. So G, 9 and 3 is going to be 12, 9 and 4 is going to be 13, we pick the 13, same with H. For I, 13 and 1, 14 hours for to finish G, 13 and 3, 16 hours to finish H. You can't start I until the 16 hours it took to finish H. F, and I both feed into J. So pick the biggest. So 16 and 4 makes 20. 10 and 2 makes 12. So we have to wait for I to complete by 20. Now, once you've filled in your forward pass, then we can fill in the back pass. And that's the latest possible finish time. Now, the latest possible finish time I can start J is going to be 20 plus 3. So I can start that one first of all, and that's going to be 23. And the reason for that is that it's always just those two added together. Okay, so although we can finish that a lot later, that one's always the one that you're limited to. Now the rest of them is always about what's the very latest you could do it. So on this one, we're looking and thinking, how can J, what time do I have to finish these two activities so that J can still be completed by 23? So they both must finish by 20. That's the very latest they can both finish, because if they both finish by 20, then you can still complete J for an extra 3 hours and finish by 23. So 20 is the answer I'll put in both there and there. Okay, onto this one. 20, take away the 4, makes 16. So 16 is the latest time that we can start I. So because it's the latest time we can start I, it's the latest time we can finish both of these. Okay, notice that it's not just the sum of these two. 13 plus 1 is not 16, but G is what we call a floating activity. It can take a bit more extra time. It could start at 13. This 1 hour it takes to do G can be done at any time as long as it's finished by 16, because then 16 is how long it takes for I, and so on. All right, so you could just go through. 16 take away 1. 13 is the latest time we can start that. 13 is the one for that, and you're picking the smaller out of each of them. There's no point in finishing this at 15, because that takes 1 hour and goes to 16, because if you finish up by 15, this is going to cause H a problem. Okay, so although this can finish as late as 15, these two are limited. Okay, but always be wary about the difference with these ones. Okay, because sometimes that is a possibility that you could have picked 15 if there was only one activity that affects it. Okay, so what have we got next? So we've got F. We talked about this already. That's going to be 20 because it has to finish and give J a chance. For C, it's got 3 different choices. The 13 take away 3 is 10. So as long as this finishes by 10, nothing to do with the 9. As long as this finishes by 10, that could take 3 and still finish by the 13. That would be okay. Right? 13 take away 4 is 9. Now it's no good finishing by 10 because then this one wouldn't finish in time. So this is definitely limiting it. Right? So although 10 doesn't affect D, 10 does affect E. So I have to put at least 9 in there. Right? You're picking the smaller out of them. 20 take away 2 is 18. Now it's no good putting 18 in there. Even though F would finish, it would massively affect D and E. Okay, so you always pick the smaller out of the choices. 10, 9, 18. The 9 is the one we put in there. Now for this one, this has only got F. Alright, so this is only going to be affected by F. So on this one just here, 5, sorry, let's go back to that. There we go, 9 take away 4 is 5. As long as that finishes by 5, it gets that one. But this one is 18. Alright, it's not the 10. As long as that finishes by 18, this activity here would still be okay. Alright, so that could take anywhere up to 18. Therefore, it's going to still mean that F can still finish on time. Okay. So that finishes 18, that takes 2 hours, finishes it by 20, and that still doesn't affect J. All right, so always be wary. On your back pass, it's the difference between these two. Okay, right, so all that's year 1 practice. So if you do need some more practice of that, there's plenty of questions in your summer work packs to do, or in your textbooks, so have a quick go at some of those. So something else you did in year 1 was practicing critical activities, floating activities, and critical paths. So what I'd like you to do is just see if you remember how to find the critical activities, the non-critical activities, and the float time for those non-critical activities, and also figuring out what the critical path is. So just pause there, see if you can remember doing it yourself. Okay, so a quick reminder then, a critical activity is anything that has to start at the earliest possible start time. If you do the whole activity in time, it should just finish by the latest possible finish time. So activity A is an example of a critical activity. It has to start at 0, because it takes 5 hours, it will be finished by 5. In other words, these two numbers should add together to make the last one if it is critical. B is an example of a non-critical activity. It could start at 0. It takes 10 hours, so it finishes at 10, but then you've got 8 hours sitting around doing nothing, okay, until you get to 18. So this one is what we call a non-critical activity. Now those 8 hours are what we call the float time. How much time we could float this 10 hours between 0 and 18. This could start not at 0, but at 8. Do the 10, still finish by 18. Okay, so this is a non-critical activity. Okay, so let's just go through, look for the critical activities. Well, 0 and 5 is 5. Okay, so that's definitely one. 5 and 4 is 9. 9 and 4 is 13. 13 and 3 is 16. 16 and 4 is 20. 20 and 3 is 23. Okay, so we've got these critical activities. Now this line of critical activities that are all linked, okay, so just be careful because sometimes you might have more than one critical path, and if they intersect and cross over, always keep an eye on these numbers. So 0 finishes by 5, goes to 5, finishes by 9, 9 to 13, 13 to 16, 16, 20, 20, finishes by 23. Okay, if you have more than one critical path and they intersect, some people get mixed up on which ones are the critical paths. Just be careful. Okay, so it's quite straightforward, but you just need to be wary that the examiner might try tricking you up with it. Okay, so in this case, it is straightforward. There's only one critical path. There it is. And so it's a line of critical activities. You will always have at least one critical path. You may have a situation where every single activity is critical. All right, so just be wary. There's lots of different variations, but you would always have at least one critical path. If you don't have one critical path, you've definitely done something wrong. Okay, so the non-critical activities, D, G, B, and F. Now, with each of those, if you go through, B has this extra float time, and you can figure it out by just doing 18 take away 10 is 8. D is going to be 3. D is going to be just 1. So 13 take away 3 is 10, but it starts at 9, so that's going to give you just one more hour. Okay, an easy way of doing it than that would be doing 9 plus 3 is 12. How much more time to get to 13? Be easy looking at that way. So 9 plus 3 is 12. We got one more hour free. F, if I started at 10, it takes 2 hours. I would have a good 8 hours to sit around till 20. So that's 8 hours of float. Okay, G, if I started at 13, it takes 1 hour, that would be 14. I'd have 2 hours sitting around to get to 16. So it's a float times 16. And there's the critical path. Notice you're writing that critical path down like that, like a trail from one side to the other. Okay, so everything you've just done there is covered everything you should know about critical path analysis from year 1. None of that should have been new. What we are going to do now is look at what's new in the second year. Okay, so if you've got your notebooks, grab your notebooks out because you need them. Okay, what we're going to do is we're going to look at what's called a Gantt chart. All right, so just in your notes, get the title down as Gantt chart. And a Gantt chart is a way of showing this activity. Now, if you've done anything to do with business or you do any sort of business work, you might have already seen or heard of a Gantt chart before. Okay, it's an order of activities. And the way we do it is a one-dimensional chart. And the one dimension that goes at the bottom is always to do with the time. So it starts at 0, finishes by 23. So it's equally spaced out, 0 to 23. So if you've got squared paper in your notebooks, it's very easy for you to draw that out and just pause there until you've drawn it out and copied mine. Okay, so that's what we're looking at doing, just one dimension to it. A bit like a box and whisker diagram, only has one dimension. Okay, so once I've done that, what I need to do is I need to show these activities on this Gantt chart. And I could do it a little bit like a box and whisker. I'm basically drawing the boxes above this line. So I'll start with activity A. Keep it nice and neat. Activity A is going to be a rectangle starting at 0, going up to 5. I don't connect it to this line because it's one dimensional. So I just have a little bit of space in there and I put activity A like that. And just so you've got space in your notebooks, notice there's quite a bit of space above it. So leave yourself a bit of space above it because you're going to put all the other activities in on this. Now activity A has to start at 0, has to finish by 5. So it clearly shows on the Gantt diagram that's how much time it takes and that's when it has to be done. Okay, right, activity B also starts at 0. And if, well, it doesn't have to start at 0, of course. I'm starting it at the earliest possible start time. So I'm pretending activity B has to start at 0. And then it finishes at D. But this is where it's important. Activity B is not critical. It has some extra time. We know it's got an extra 8 hours of float time. In fact, it could have finished all the way up to here, 18. So the way I show that on my Gantt diagram is with a dotted line, just to say, look, I can float it all the way up to 18. This activity B can be done anywhere along here. Now I've drawn it at the earliest possible start time. Sometimes an examiner might say using the latest possible start time. So you might have drawn B here and shown the float time at the start. All right. Generally speaking though, get used to just doing it at the start. All right. But don't forget to show that float time on your Gantt diagram. That is vital. Okay, so the job now is just to basically put in all the others, each with their own line. Start with activity C. Activity C would be next. That could start at 5, takes 4 hours, finishes at 9, is critical, so that's it. Okay. Now some people draw them one after the other. You don't have to. Right? And in fact, in some ways, it's probably neater to draw one on each of its own lines. That way, you're not going to end up getting into a pickle. In a lot of ways, it's better to actually keep it all separate. Okay, I've seen other people do it, and they draw the critical activity along the bottom. Okay, so they connect up the actual critical activity on the bottom to show it. And you might see questions where it's been done like that. So the A, the C, the E, the H, the I, and the J are all along the bottom as one big rectangle split up. Okay, see what I mean? You can drop C down here. So just be aware that might happen. You don't have to do it like that. And in fact, it's probably better to keep them separated out. Okay, so what's next? Well, we've got D, starts at 9, goes 3. And I could probably pause there and give you an opportunity just to finish off the rest yourself. All right, but if you want to keep your notebooks nice and neat, you might want to wait till I've done it. Okay, so let's just go through then. Activity E starts at 9, takes 4 hours, finished by 13. Oh, sorry, D had some float time, didn't it? So, yeah, starts at 9, finishes by 12 after 3 hours, float time of 1 hour. E was critical low, so that goes straight in. F starts at 10, 2 hours, but it got loads of extra float time up to 20. Okay, G starts at 13, got 1 hour, 16, got a bit of float time. There we go, put that in. H as well, 13, 3 hours. And then finally, I and J put in there with no float time at all. And you can see what I mean now. The C, the E, the H, the I, and the J could have all been dropped to this bottom line and then just had the non-critical activities floating above them. Okay, so you might see that in some questions, so just be very wary. All right, but this is one answer that you can do, and you're definitely going to get the marks. There's no concern there about having to worry about which order to put things down. Okay, right, so in your notebooks, make sure it's nice and neat. That's an example of a Gantt chart from an activity network. Okay, pause if you need more time. Okay, so we've just talked about it being one-dimensional. So let's make it a little bit more complicated. If you imagine that we've got these activities and this is all the time it takes, but then also some of these activities might require, let's say for example, a number of workers. So activity A may take 3 workers 5 hours to do, whereas activity B might be a one-person job, and that's why it takes 10 hours, or it might just be one person because there's only one skilled labourer in that part. So there's lots of reasons why you might only have a set amount of workers. So what I'm going to do is just add an extra dimension to this. I'm going to put in this bit just here. This is the number of workers you need to do each of these activities. Now we're not going to show that on our activity network. Okay, so you don't need to show it on your activity network at all, but we do need to be able to show it on our diagram. Now it's no good doing a Gantt diagram, because a Gantt diagram, or the cascade diagram as it's called, just noticing up there, sometimes it's called cascade, but the Gantt or cascade charts are one-dimensional. Okay, what we're looking at is what's called a resource histogram. And as you know from your GCSEs, histograms are two-dimensionals. Right? They have frequency density going up the side, so they are a two-dimensional chart. So in this case, we can do that now. We can have time going along the bottom, the same as the Gantt chart, but we can have number of workers going up the y-axis. Now, grabbing your notebooks, title is resource histogram, and we can use a resource histogram to show this. So what I might say to do, if you haven't jotted this down already, I hope you did on the previous question, but if you haven't got that activity network down, put it down now, but include this extra bit of table. Okay, so the number of workers. So just pause there while you've got those few notes to put down. Okay, so what we're going to do is just going to reduce that, give yourself a bit more space. And the chart looks like this. Exactly the same as the Gantt diagram with duration going along the bottom. But this time I'm going to have number of workers going up this y-axis just here. There we go. So number of workers going up, duration going along the bottom. And what I want to do is I want to show each of these activities, not just with the time, but also with the number of workers. So activity A, for example, does exactly the same as what you do with the Gantt diagram. Right? But this time, because it's two-dimensional, we're not just going to float it anywhere up this side. We're definitely going to start at this bottom corner. It starts at 0. It takes 5 hours, but it takes 2 workers. So I go from 0 across to 5, but I go up to 2. So it's going to be a rectangle like this. So that's what activity A is. Now I could do the other activities like activity B like I did before, but what's a good idea to do is always to draw those critical activities along the bottom. This is why sometimes people do it with their Gantt diagrams, right? But certainly with a cascade diagram, it's a good idea to put the critical ones along the bottom first. Okay, so I'm putting in activity C. It starts after activity A. It takes 4 hours. So it finishes by 9 and it takes 3 people, keeping an eye on which one it is. So there we go, C is 3. E is next, starts at 9, straight after this one, takes 4 hours, finishes by 13, and E has 2 people. So there we go. So we're just literally just going through and just drawing our critical activities. H starts at 13, finishes by 16, has 1 person. There we go. Right, I starts at 16, takes 4 hours, finishes by 20, and has 4 people. So there we go. And then finally, activity J, 2 people, starts at 20, finishes by 23. So I've shown the critical path along the bottom. For it to work by 23, I must have at least 4 members of the workforce, 4 people, because at this stage just here, we've got activity I going on. Now the other activities, I would say, depending on what the question says, right? The question might say put in the activities at the latest possible finish time, or they might say put in the earliest possible finish time. If they don't say anything, you do like I'm about to show you now, which is putting the activities at the earliest possible start time. So for example, activity B. Activity B starts at 0, takes 10 hours, so it's going to go up to here, and activity B needs 3 people. Now when I draw that on, what I do is I drop each part of it down to the lowest level. So for example here, when activity A is going on, if I've got 2 people working on A and I need 3 people to work on B, I would just need 5 people. All right, so I need 2 for activity A plus the extra 3 for activity B, so I need 5 people. But when I get to this point just here, 3 people were needed for activity C plus 3 people for activity B. So it's actually going to go up a bit there. Okay. Then when I reach this point just here, in the last hour, I'm going to need 5 people again because I've got activity E going on. So what I end up with is this sort of shape. All right. So it goes across, but then jumps up a little bit there and then goes down here. So you're sort of squishing everything down to the lowest possible point. All right, as if they're made of jelly and they're just sort of flopping down to the nearest base. Okay, it's the top line that's important. That's what the examiner's going to be looking for. Have you got this sort of skyline bit correct? Okay, so it shows how many people you would need at any given point. So at this point just here, 2 hours, I would need at least 5 people for it to work just there. Okay, right, now I need to go through and I need to do that with all my critical activities. So it starts getting a bit awkward then, because when you get down to D, that starts at 9 just here, D needs 3 people. It's got 2 for E, it's got the 3 for B, and it's going to be another 3 there. All right, but once it gets to that point, then it sort of sags down here. So I'll show you what I mean. There's a bit for D there, and then there's a bit for D there. Okay, because at this point just here, it needed all these people, but at this point just here, it only had E. All right, so we got this extra part up here. Right, what about F? F starts at 10 just here. It takes 2 hours. Okay, and needs 5 people. So what I'm going to have is I'm going to have F going on just there. All right, so F goes on just there. What have I got? I've got G left, haven't I? G starts at 13, just here, takes 1 hour and 4 people. So I can put G in just here. Oh, sorry, starts at 13. So there's G over here. Right, so that's the situation I've got. And that's my resource histogram drawn with the activities at the earliest possible start time. And that's what we mean by a resource histogram. And we're looking for this sort of top line that I'm sort of tracing out there. That's what's important. Everything sort of filled in down to the earliest time. Now, what you could have is you could have someone in charge, a manager, looking at this and going, right, I know between 10 hours and 12 hours, I'm going to need 10 people to do these activities as early as possible. I'm going to need 10 people. All right, so that's why it's important to look at any given point. As long as people are multi-skilled, then you can actually choose or spot areas where it's got the most members of staff. Whereas activity 12 to 13 only needs 2 people. You're going to have people stood around doing nothing for a good hour. All right, especially if there was 10 people then, and then only 2 people here, you've got 8 people doing absolutely nothing for an hour. Okay, so that's what we call a resource histogram. Now, resource histograms do lend themselves to more technical questions then, because you do get questions like this. Let's say the company only has 6 workers, all right? So what you're looking at now is you might get questions like this. You might say, given that the company only has 6 workers, what impact does that have on the latest possible finish time? Does that mean that we can't finish by 23? Because if we've only got 6 workers, we can't do these activities at the same time here. And we can't do these activities at the same time here. Right? So the question is, can we move some of these things about, ideally, so they don't affect our critical path, right? Which means that we can still finish by 23 and we don't go over 6 workers. Now, this is an example what we call resource leveling. We're trying to level things out below a given point, or just level things out so we're reaching a minimum here. Now, clearly, I can't go below 6 without massively affecting this, because C and B have to happen at the same time at some point. All right, so we're going to need 6. The 6 is fine. If I want to finish by 23, it's the D and the F that's messing me up, isn't it? Now, D and F aren't affected by each other. All right, so I can move these about if I wanted to. The question is, how can I move these about? Now, if I look at this, just thinking about sort of moving it, I could definitely sort of move maybe D across a bit, and then a bit of F will float down. I could move D across so it falls down here. F's a bit of a problem, but what I could do is maybe push F further along and then G further along, because I noticed that G has to happen after D, but it doesn't have to happen after F though. In fact, F can be finished later on. You can take F if you want to and chuck it in there. That would work, wouldn't it? Because if I put F in here, into this space just here, then I can still finish B. I can wait around a bit, then get some people to do F just here, and that still means that J could finish later on. Okay, in fact, F could go all the way up to here if you wanted to. What you can't do with resource leveling though is say, right, F takes 2 hours with 5 people. Now that's the same as 5 hours with 2 people. That's not true. All right, so you can't rotate these rectangles or change them about. They must be the same. 2 hours, 5 people. Okay, but we can move them so they fit. So an example of resource leveling is a bit like this. We could take maybe the 6 works 20 days. So we could take the G and we could move that further to there. That wouldn't actually affect it at all. As long as G finishes by 16, that would be okay. Now, if I do that, that frees up a space for F to go into. Okay, and F could fit neatly in there. In fact, those two could be the other way around. That would work just as well. And then you've never gone over 6 workers for F and G at that point, which is great. Now, to sort this bit out, you could push D back another hour, and they could link up then and make D. And at that point, you've got everything done by 6 workers. You've definitely still fitted here because you've rearranged some float times and you've leveled it off. Hence what we call resource leveling. Right, now there's plenty for you to be practicing. You've got some practicing from your textbooks. You've got your practicing from your summer work. It'd be worth making sure that you practice some Gantt diagrams and some resource histogram work as well. That's a very important point, like I say in there. I've seen people doing resource leveling before and forgetting either about critical paths or about these. Now, sometimes you might do resource leveling and have to push this out. Say, for example, if G had to snug down here, you might end up pushing things forward by an hour. That might actually happen. Okay, so resource leveling does not mean you get a solution that fits with this latest possible finish time. But you should always be wary of the order of the activities and which ones affect each other. That's exactly what I just said then. Sometimes you have to extend that finishing time.